Alright, welcome back. This is the second part of this video where I go through P6 exam science paper for a student, and we can all learn together as we watch this video, read the questions and the answers. Now, Muhammad conducted an experiment using 3 identical pieces of paper, A, B and C. A is not folded while B and C are folded as shown below. Now it talks about, this is the exposed surface area, and here when you look at this table, right, time taken for paper to reach the ground, it seems to be talking about air resistance here, like another P6 topic. So if you're not a P6 student, you can kind of skip this question, okay? Muhammad dropped each piece of paper from the same height and measured the time taken for each piece to reach the ground. Right, by right, if there's more surface area here, it will be in contact with more air as it tries to come down. Whereas, of course, it will not come down horizontally, but let's imagine they all come down horizontally. This would actually be in contact with less air, and this will be even less. So air resistance is like something pushing against a falling object. Okay? So air resistance is like something pushing against. So here there's more air pushing against the paper. Here, the same size paper, as in identical piece, but now folded, have less air pushing against it. So, what is the relationship between the surface area of the papers and the time taken for them to reach the ground? Remember, we talk about relationship. You must use the relevant word, surface area of the papers, and the other word will be the time taken for them to reach the ground. And notice that the larger the paper, the more time it takes, and the smaller the surface area of the paper, the less time it takes, means it reaches there much faster. So the bigger the surface area of the papers, the longer it takes to reach the ground. I will close one eye and accept this, okay, even though I didn't write this down, because there's no other surface area in this question, so I can't misread this purposely even if I want to. So yeah, 1 mark for this. Next one. Now it's an application question. Alright. Now this is a person like a wing glider, no, kind of suit, a wing suit. People do kind of crazy stuff, right? And this is of course one crazy stuff that Mr. Long will never do in his life. The diagram shows a man wearing a wing suit. He uses this wing suit to glide when he jumps out of the plane. Now if you are curious, you can look at this thing called a flying squirrel. So a flying squirrel doesn't fly. A flying squirrel has something like this, a kind of thin flap of skin around the armpit area that helps it to glide. Why? By increasing the surface area like this, right? Increasing the surface area, so it increases the wind resistance. That means that it will slow down its fall. Slow down its fall. Just like if imagine another example is a parachute. If this is a person A, person B, you will want to have a parachute with a huge canopy, so it will slow you down as you fall. You don't have a parachute that's like that only, with a small canopy. You probably land very fast, okay, more faster than you would prefer. There are 2 flying positions, J and K. This one is spread out. This one is like you put your arms by your side, like when you sedia in the morning, and legs also together instead of spreading out with this flap here. And this one have more air resistance, it will slow down more. Have less air resistance, it will not slow down. So which position should he use even to flying downward faster, right? Faster, of course, we use position K. So the first one is a claim. This claim has 0 mark, okay, because it's given to you to choose J or K. Now why? It produces less friction between the man and the air. As, remember the whole idea of this question so far is for the area in contact. Less area in contact, less frictional force. More area in contact, more frictional force. As, so you're looking for a reason, right? As there is less area, surface area in contact with the air. So the answer should be, it produces less friction or frictional force between the man and the air as there's less surface area in contact with the air, between him and the air. So a man using his wingsuit glides towards the ground. Name the two forces acting on him. The downward force will be gravitational force pulling on him. Here I think I can give you 1 mark, alright? And there is frictional force pushing against him. That's true, 1 mark. So here's 3 marks. Sorry, you can't see it. A man using his wingsuit glides towards the ground. The two forces acting on him. One is a downward force, a gravitational force. This one pulls down on him. And the other one is the upward force that pushes against him, and that will be the frictional force or the wind air resistance. Friction, okay, check. I will accept this. However, if you're going to write, you either write as friction or write as frictional force. Don't change it to friction force. There's no such term. Next one. Now, Kenny filled a bottle with water to the brim and covered it with aluminum foil. He left the bottle of water in the freezer overnight. Freezer, so probably about change in state of water. When he took the bottle out the next day, he noticed the water had turned into ice and some of it was sticking out of the bottle. Now, this idea is actually not necessary to be tested. So I'm not quite sure why this question part B is being tested, because it's not in syllabus at all. However, they probably can argue it's just about the observation. So let's talk a bit more in a while. So what is freezing? So state what is freezing. Now in the recent years, you will find, if you look at the past PSI questions, there will be a question almost every year about stating what something means. In other words, this kind of question will require you to memorize the definition. Like if I ask you, state what is pollination, state what is melting, state what is germination. You got to be able to explain in the scientific terms. You got to say that pollination is the movement of pollen grains from the anther of a flower to the stigma of another flower or the same flower of the same kind. You need to know the definition. So state what freezing means. Freezing means the liquid loses heat, correct, and change states. Didn't mention states, okay. Change into a solid. So liquid to solid means change state, right? At a fixed temperature. Very good. They talk about the fixed temperature portion, because a freezing happens at a particular temperature, a fixed temperature for a different liquid. For water, it's at 0 degrees Celsius. But here, there's no mention it's about water. It's just state what freezing means. So I'm very glad this answer is a very generic answer that didn't talk about 0 degrees Celsius only. If you talk only about 0 degrees Celsius, your teachers will have a headache to give you any marks or not. So if the answer is freezing happens at 0 degrees Celsius, that is wrong. From this observation, what can Kenny conclude about water when it flows? Notice that this is to the brim. There's no gaps here. So I'm going to draw a line across. Notice somehow there is some expansion. So this part, it went up. Somehow water can expand when it turns into ice. So the volume of water increases when it is frozen. This is true. Now this is not in syllabus. Alright, but this is something you don't need to explain scientifically. Therefore, maybe the teacher can argue that, oh, I can still design these questions and still test this, because you're not supposed to or not required to explain, you're just required to observe and state the observation. I think that's a fair thing to say. Okay? Right, let's move on. Kenny wanted continuation. Kenny wanted to watch a documentary which showed a rock cracking due to ice. Water collected in the crack froze during winter and then melted when the temperature increased. This continued over a long period of time until the rock split in two. So this question is tied back to part B, where you observe that volume of water increases when it's frozen. So imagine if water is trapped in the gap. When water freezes, alright, water will expand, pushing the rock aside ever so lightly. And next time again, new amount of water fill up the gap here. When it froze again, it will push it apart ever so slightly. And over millennia, over decades, over a long period of time, it will crack the rock. That's basically what it means, okay, how it works. The rock was split apart due to the expansion of the ice again and again. Okay, it's a 2-mark question. Let's figure out how the 2 marks is given. Usually mark allocation for the teachers, they don't just give you 2 marks for no reason. The 2 marks are usually for 2 ideas, like 1 evidence, 1 claim, 1 evidence, 1 reason, or 2 reasons. So in this case here, you are already given the claim that this will crack. right? And you're supposed to explain now how it's split into two. So explanation wise, you can talk about, okay, how would I try to do this? Let's try. As the water flows, it expands and pushes the rock to either side slightly. Okay, I think this is only deserving of 1 mark because it only happened once. But here talk about it continue over a long period of time, right? So, how do I get the second 1 mark? When the ice melts, then the ice melts. No marks for this. 1 mark for this. Next time, more water fill up the gap, and when it flows, it expands again and pushes the rock apart. Same concept as before. So I think this answer is very good because it talks about expansion of ice again and again. What is the difference between that answer and this answer? This one talk about water freezing and expanding. Alright, expansion of ice again and again. I think I will give full marks for this. It's a very concise answer. How is the mark given? Firstly, I see the part about expansion of the ice. Secondly, I see the idea about the repeated expansion. So the first mark is for expanding ice. Right, second mark is for the repeated expansion. Although I think if it's a forces question, is for pushing aside. The teacher might want to see in the answer about the pushing the rock to both sides. Especially the ice that pushes the rock to either sides. Again and again. I think I will improve it in this way. The rock will split apart due to the expansion of the ice that pushes the rock to either side again and again. So keep pushing to one side, to both sides again and again. Keep pushing again and again, again and again, and again and again until it cracks. So I think that will improve this answer to give a short and sweet 2 marks answer. Okay, let's go on. Electrical system. A lot of life science question. Study the circuit below. All the bulbs and batteries are in working condition. So no answers can be about, oh, the bulb has fused or is spoiled or whatever. Okay, now unless they tell you so. One of the bulbs fused, you're not sure which one. What's the smallest number of bulbs that could remain lit? Give a reason for your answer. So there are 2 parts to it. The first part is a claim. Let's say that could remain lit. Now, let's say if either of these 2 bulbs fuse, no current can flow through. I'm going to highlight for you and see. So current flows up from the plus. Convention is from plus to minus. Okay, at this point it splits. Alright, it can take either path or this path. Alright. As here it's moving this way, it's this way, okay? This way. So if either B1 and B4 were to fuse, no current will flow through. If B2 were to fuse, current can still flow through here like this. If B3 were to fuse, current can still flow through here. Alright, here. So smallest number that could remain lit. Now, you cannot write 0 because it remain lit. How can 0 bulbs remain lit? So you cannot use 0 as your answer, right? Don't be tricked by the wordings here. So that could remain lit. Now, smallest number that can remain lit is 3. Answer here is 3. And there's 0 for this. Why? So talk about when either B2 or B3 fuses, current can still flow through the remaining 3 bulbs. Okay.